Hello everyone. In this video, we shall solve one problem on projection of point. This is our problem statement. Draw the projections of point if it is 30 millimeters above HP and 20 millimeter in front of VP. For better understanding of problem, I have drawn three-dimensional sketch. Okay. It is given that the point is 30 mm above HP, 30 mm above HP and 20 millimeters in front of VP. From this description, it is clear that the point is in first quadrant. It is some millimeters above HP and some millimeters in front of VP. This is the direction of observer. Now, to draw front view of this point, we need to project this point on vertical plane. For that, draw the horizontal projector through A. This projector will meet this vertical plane at certain point, and that point is nothing but the front view of this point. Remember, front view is always denoted by small letters with dash. The front view of this point is small a dash. Now, to draw a top view of this point, we need to project this point on horizontal plane. For that, draw vertical projector through point A on horizontal plane. This projector will meet at certain point with HP, and this point is nothing but its top view. Top view is denoted by small letter without dash. A dash is a front view and A is a top view. Now, after that, this horizontal plane is to be rotated by 90 degree. This horizontal plane is to be rotated by 90 degree. After rotating this plane by 90 degree, what will happen? This top view will come exactly below this front view. Exactly below this front view. This is the new position of top view after rotating this horizontal plane through 90 degree. Now let us draw front view and top view in two-dimensional plane. For that, first of all draw XY line, which we call as reference line. Now this distance is 30 millimeter above HP. This is 30 millimeter, this vertical distance, and this horizontal distance is 20 millimeter in front of VP. This is the front distance, 20 millimeters. The same distance we will get here, and this distance we will get here, and as we have rotated this plane, horizontal plane through 90 degree, these two distances are same. These two distances are same. This is 20, this is 30. Okay, now let's draw front view. To draw front view, we have to draw vertical line with 30 millimeter length. This is a projection line. It should be drawn thin. And what is this? It is front view. And this distance is 30 millimeters. And to draw its top view, draw this. This is the front distance, 20 millimeters. And this is top view. How much is this? 20 millimeters. 20 millimeters. Here one should not write millimeter, the unit. You just put the numbers, because at the end of the drawing we are supposed to write a common note for all dimensions. what should be that note? All dimensions are in millimeters. All dimensions are in millimeters. In this way, we have drawn front view, which is above xy, and top view, which is below xy. Remember, very important point, whenever the point is in first quadrant, the above distance come above xy line, and front distance, as it is rotated through 90 degree, this front distance will come below xy line, below xy line, below. When it is said above, we have to go above xy line to draw the front view, and when it is said below, then we have to go below xy line for drawing the top view, I hope you must have understood this clearly. See, again, for better understanding, what we will do, we will have some demonstration with hand. See, this is vertical plane, this is horizontal plane. The point is in first quadrant. For drawing front view, we have projected the point on vertical plane. That is, we have drawn projector, horizontal projector through point on vertical plane. It gives you front view. To draw a top view of that point, we have drawn vertical projector through that point on horizontal plane. This hand is a horizontal plane, and after getting the front view and top view, we rotate this horizontal plane through 90 degrees such that front view will be here on this my left hand, and top view will be on right hand. The top view will be below front view. Why it is done? Because this is a three-dimensional thing now, and to convert this three-dimensional thing into two-dimensional plane, because after all we are going to show each and everything on two-dimensional plane. For that purpose, we rotate this horizontal plane through 90 degree, and on this two-dimensional plane, see, this is VP and this is HP. The portion above XY line will be the VP, and the portion below XY line will be the HP. VP, HP. Portion above XY line VP, and portion below XY line HP. It's better to write here. This portion is for VP, and this portion which is below XY line is for HP. Now let us make little changes for further cases of point. Okay. Now, what happens if suppose the point is in VP? Okay, it is 30 mm above HP, and we will make this change, and is in VP. Now the point is in VP. Okay, and how much it is above? How much it is above HP? It is 30 mm above HP. Okay, 30 mm above HP. This distance is 30 millimeters. See, this is the point which is in VP and 30 millimeters above HP. To draw front view of this point, we need to project this point on vertical plane. As the point already is in VP, there is no question of projecting this point on vertical plane. The point itself will act as its front view. The point itself will act as front view. And to draw its top view, we need to project this point on horizontal plane. If you project this point on horizontal plane, we will land on XY line. That's why this point will be its top view. This point will be its top view. Let me rub out earlier lines. Okay. Now from this figure it is very clear that front view is above XY and top view is coming on XY line as the point is in VP. How to draw projection of this point? This is XY line. See, to locate front view, we have to draw the vertical line with 30 millimeter length. What is this projection line? It is drawn to draw the front view. A dash is a front view. At what distance? 30 millimeters from XY. And where is the front view? It is exactly here on XY line. Sorry, this is the top view. This is the top view which is on XY line. A dash is a front view and A, which is on XY, is a top view. Now let us make reverse of this. Let us reverse the case. Okay. Now what we will do, the point is in HP and in front of VP. The point is in HP and some millimeters in front of VP. Let us take earlier distance, 20 millimeters in front of VP. See, we have to keep the point in HP. Okay, this is the point, and it is how much in front of VP? It is 20 millimeters in front of VP. It is 20 millimeters in front of VP. Now let us talk about its top view first. To get top view of this point, we have to project this point on horizontal plane. As the point is already in HP, there is no question of projecting this point on HP. The point itself will act as top view. What is this? This is top view. The point itself will act as top view and which should be denoted by small letter A. To get front view of this point, we have to project this point on vertical plane. When we try to project this point on vertical plane, we will land on XY line. This projector, horizontal projector, will meet XY line as the point is in HP. This point is nothing but its front view. And as earlier we have discussed, when we rotate this horizontal plane through 90 degree, this top view will come below, exactly below this front view. What is this? Top view. Now let us show front view and top view on two-dimensional plane. This is XY line. Where is the front view? It is on XY. Somewhere you locate front view. Then take this distance. See, these two distances will be same as we have rotated this plane through 90 degree. Okay. Go 20 mm below xy to get top view of that point. Top view of that point. This distance is how much? 20. In this way, we have completed 3 cases by taking one example. Okay, first case was the point was in first quadrant with certain distance above HP and certain distance in front of VP. After that, we had kept the point in VP such that that front distance will be 0 and it will have some uh, vertical distance, that is above distance. And in the third case, we had kept the point in horizontal plane, therefore its vertical distance will be 0 and it will have front distance as it is in HP. Okay, in this way we have covered the 3 cases. Very simple. Just imagine the quadrant, the position of point. Okay, when it will have both the distances above and front distance, when it is in first quadrant. When it is in vertical plane, it will not have any front distance because point is lying in VP. It will have only above distance. When the point is in HP, it will not have any above distance. It will have front distance. And above distance is always taken above XY line and front distance is always taken below XY line. This is valid for the point which is in first quadrant. Thanks for watching. We will meet again in the next video with another problem. Till then, goodbye.